Good morning, student. Let's start today's class. In today's class, we are going to discuss about quantization. Previously, we have seen that for in the method of analog data digital signal conversion or the encoding, we uh, first of all we digitized our analog signal. Okay, we first of all our first step of that encoding is that to digitize the analog signal into digital signal, and this process is called digitization. Okay, and this process digitization have three steps. Okay, one is sampling, one is quantization, one is encoding. Okay, and we already discussed about sampling, what is sampling. Okay, and the next step is quantization. Today we will discuss about what is quantization. Okay, what is quantization? Okay, the result of sampling is a series of pulses with amplitude value between the maximum and minimum amplitude of the signal. After sampling process, the sampled are quantized. Okay, that means uh, we have already known that uh, in sampling process we get a sequence of or a series of pulses with amplitude value. Okay, in a particular time interval. Okay, or sampling interval. Okay, or sampling rate, which is called sampling rate. Okay, and by using that sampling or that sequence of or that series of pulses, we in the quantization process we can use that series of pulses and quantize them. Okay, the process of quantization. Now we can see, we will see what is the process of quantization. That means what is done in quantization process. Okay, uh, there is four steps or four process is done in that quantization process. That is, first one is we assume that the original analog signal has instantaneous amplitude between V min and V max. That means we define we assume that sampling. Okay, that original signal, or sorry, that's not sampling signal, that analog original signal have V, what is the V min and V max. That is, what is the max amplitude of that analog signal and what is the mean amplitude of that analog signal. We assume that. Okay, and next step we what we do next step, we divide the range into L zeros and L zones. Each height is it. That means we divide that what that that analog signal into some number of zones. Okay, in vertical ways. We'll see the figure for better understanding. First of all, we understand the process, and next we see the practical of the waveform, how the waveform made. Okay, then you understand all. Okay, first, then each of height, that means the height of the uh, zone or the height of the divide or range is always delta. That means it is delta. Okay, and delta is V min minus V max minus V min by L. Remember this formula. Okay, and we assign quantized value of 0 to L minus 1 to the midpoint of each zones. Okay, then we approximate the value of the sample amplitude to the quantized value. Okay, now let's see the figure for better understanding. Okay, first we take a example. As a simple example, assume that we have a sampled signal and the sampled amplitude are between minus 20 volt to plus 20 volt. Okay, we decide to have 8 level. Okay, we decide the level of zones or the 8 levels. We can decide 8 or 7 or 5, anything. Okay, this means that delta is 5 volt. Delta is, how can we calculate that delta? That is V max minus V min by L. Okay, here what is V max? V max is 20. Okay, 20 minus V min is 20. Okay, minus of 20. Okay, divided by L is 8. Okay, this is 8. Then this is what? 20 20 40. Okay, by 8, which is 5. Okay, so we get delta is 5. Okay, now see the waveform. Okay, this is the sampling waveform. Okay, this is one sample. Okay, and in this sampling, okay, in this sampling, what happened? No, 1 minute. We get the sampling. This is the this is the original analog signal, and we take our sampling. Okay, this is the original analog signal. Okay, this is the original analog signal, and now we get our sampling. You know the process of sampling. We take samples or pulses in a time interval. Okay, in a fixed time interval, or which is called sampling rate. This is sampled. Okay, and this is sampled. This is one sample, this is one sample, this is, and this is, and this is, and this is, and this is. Okay, and the amplitude is written above every sample. Okay, above every sample. Okay, then in the process of what in the process of quantization. Okay, first of all, we what we first we calculate our delta or zone. This is 1 zone. Okay, this is 1 zone. Okay, this is 1 zone. Okay, and these zones. Okay, due to we calculate our delta is 5. Okay, you see this is minus delta, this much minus delta, so this is minus 5. Okay, this is delta, this is 5. Okay, and this is 2 delta, 2 minus delta, that means 2 into delta means that is 10. Okay, and the first sampling amplitude is minus 6.1. Okay, so that's minus 6.1 is placed between minus delta and minus 2 delta. Okay, since delta is 5, that means this minus 6.5 is placed between minus 5 and minus 10. Okay, this minus 5 and this is minus 10. Okay, similarly all the sampling is placed between the zones. Okay, the first process is complete in our quantization, that we divide the sampling in a vertical zones, some vertical zones. Okay, and the height of the zone is delta. Okay, and the delta is calculated in the formula of V max minus V min by L. Okay, number of divide. Okay, here we use number of 0, number L is 8. Okay, and next is we quantized, or we the main motive is in the quantization process is we assign a quantized, or we assign a value to the every sampling, okay, or we get amplitude of every sampling, but and the amplitude is uh, in the form of or the amplitude of that sampling is not perfect. So uh, we put some value or quantized value to that sampling, or every sampling to the every sampling, okay. In this or the process of putting the value or quantized value of every sampling is called quantization, in the process of quantization, okay. And here the last process of quantization is putting the or giving the quantization value. Here you see this is quantization code, okay, this is our quantization value. And we should place the value in the middle of every zones, okay. That means this is one zones, and the middle of the zones we place the value, and the quantization value should be L, should be 0 to L minus, sorry, L minus 1, okay. Here L is 8, our L is 8, so L minus 1 is 7, up to 7, okay, 0 to up to 7, okay. And these values is always placed between every zone, okay. 1 0 1 2 3 4 5 6 7, okay. Then here you see what happened here. Normalized palm value, okay, pulse amplitude modulation value. That means previously pulse amplitude modulation value, or PCM, in the PCM, what pulse codal modulation, okay, we have seen that in sampling we get palm value, okay. This is the palm value or the sampled amplitude value, okay. Next one is normalized quantized value. Then we normalize the value, or this normalize the value, okay, into the normalized quantized value. And after that normalized error, that means normalization 1.22 is nearly equal to 1.5, okay. So we normalize that into that, okay. And the difference is normalized error, okay. And the quantization code, that the here the quantization code, the first one sample is in between 2, the code is the first sampling is the quantization is 2, okay. So here the first is quantization code is 2. Similarly second sampling is quantization code is 5 7 7 6 2 1 2 1 2, okay. At that manner the encoding is binary conversion of that code, okay. 2 is 0 1 0, 5 is 1 0 1, okay, the binary conversion of that code, okay. And here what happened, here we have taken a sample for a similar things is written here, okay, you can study. And the quantization error, remember this, the quantization error formula is SNR in dB, and the quantization error is represented in dB, equal to 6.02 into NB, where is NB is the bit per sample, okay, sample signal. That is one sampled signal have how many bits, okay, that number of bits is NB, okay. And 1.76 plus 1.76, okay, remember this formula, okay. Thank you.